Hey, it's Mr. Lineski here with your top 5 and under 5 for Unit 9 Quadrilaterals. Let's get going. Section 1, we talked about the interior and exterior angles of different types of polygons. Remember, polygons can have any kind of number of sides. When we're talking about those number of sides, n always represents that number of sides. So if I asked you to find the sum of the interior angles, that's when you are going to use this formula right here, 180 times n minus 2. So however many sides there are, subtract 2 from that and multiply by 180 to find the sum of the interior angles. Sum of the exterior angles is always 360. It's not a trick. It's always 360. If I give you one of the interior angles and ask you to find how many sides it has, that's when you're going to do 180 minus that interior angle to find what the exterior angle is. So the exterior angle would be 120, and then to find the number of sides, you would do 360 divided by 120, and that gives you 3. So that figure would have 3 sides. If I gave you one exterior angle, if I told you that the measure of the exterior angle was 36 degrees, to find how many sides it has, all you do for external angles is 360 divided by the angle. So 360 divided by 36 is equal to 10. That would have 10 sides. Rest of this unit was all about properties, so all I'm going to do is lay out all the properties for you. So number 2 was the properties of a parallelogram. Parallelogram had 5 important properties. First one, talking about the side lengths, is that opposite sides are parallel. That means we can say that these sides here are parallel to each other. The next one was stating that the opposite sides are congruent. That means that the sides opposite of each other are the same. We could also say that the opposite angles are congruent. What that means is that these angles would have the same measurement. They are congruent. The other thing, too, that we would say is that the same side interiors are supplementary, meaning that I could say angle 1 plus angle 2 is equal to 180. And if I called that angle 3, we could say angle 1 plus angle 3 is also equal to 180. Then we also had a property based on the diagonals of a parallelogram, and the diagonals bisect each other. That means that they cut each other into half. Notice they are not equal to each other, but they just cut each other in half. Alright, number 3, properties of rectangles, rhombi, and squares. So, a rectangle is basically all of the properties of parallelograms, what we talked about in number 2, and also that it has 4 right angles, and that the diagonals are congruent. So if I draw these diagonals, those diagonals are going to be the same measurement. Remember, if I draw a diagonal here, these two angles are not equal to each other, but you do know that they do add up to equal 90 degrees. In a rhombus has 4 sides that are congruent. It has diagonals that are perpendicular, and it has diagonals bisecting opposite angles. So if I drew a rhombus, these are terrible looking rhombus. These would be 90 degrees, and then we could also say that these little pieces get bisected. So if this big angle here was 100 degrees and I drew a diagonal, that means that each of these little pieces here would each be 50 and 50. And then a square is sort of all of these properties. A square is if I mush all of these figures together. It has all of the same properties of parallelograms, rectangles, and rhombi. Okay, moving on. Properties of trapezoids. If you recall, there are 2 types of trapezoids. There's non-isosceles trapezoids, and then there's isosceles trapezoids. Non-isosceles trapezoids has 1 set of parallel lines. That's called the base, or the bases. And then the same side interiors of the bases are supplementary. So what that looks like is if I drew something like this, and these are my bases, that means that these 2 angles here add up to 180, and these 2 add up to equal 180. These 2 angles do not equal 180. So it's the only ones that are on the bases. For an isosceles trapezoid, a little bit more properties. So 1 set of parallel lines, those are the bases. 1 set of opposite sides congruent, those are the legs. The diagonals here are congruent. They don't bisect each other, though. The base angles are congruent, so what that looks like is this. These are my base angles. Those would be congruent, and these would be congruent. Opposite angles are supplementary, so keep in mind if these equal 180, that means these have to equal 180. And then the same side interiors of the bases are supplementary. So that same property that we just talked about up here. And finally, the last one, kites. Property of kites, the diagonals are perpendicular, again, meaning they meet at a 90-degree angles. Keep in mind, if any time we're dealing with those 90-degree angles, wow, I can't spell and talk at the same time. Pythagorean theorem. Anytime we're dealing with the 90-degree angles, keep in mind Pythagorean theorem can be used to help you find side lengths. One set of opposite angles are congruent, so these sides would be congruent. That's this next one. And then these would be the congruent angles, and then the diagonals of the non-congruent angles bisect the angles. So these two angles are the non-congruent angles, so if I draw a diagonal through that, that means these angles get bisected. Again, if this were 100 degrees, each of these little pieces here is 50 and 50. And then it has two pairs of adjacent sides congruent, and that's what we just talked about here. So notice it's not opposite sides congruent, it's adjacent sides congruent. Hey, that's all I got for you today. So thank you for watching, and I hope you do well on the test.